In this video, I'm going to go over how to conduct a chi-square test of independence using SPSS. If you guys recall from class, we use chi-square in situations where you want to determine whether or not there is a significant relationship between two categorical variables. For this video, we're going to be using, as an example, the GSS93 subset dataset. In particular, we're going to be looking at the relationship between political ideology and the position and the respondent's position regarding the death penalty for murder. So in this case, we have two categorical variables, one political view, which is coded as 1 being liberal, 2 moderate, 3 conservative, and the second variable, position on the death penalty, is also a binary variable, categorical variable, with 1 equals favors the death penalty, 2 equals opposes the death penalty. This would be an example where chi-square of independence test of independence would be appropriate to see whether or not there's a significant relationship between them. So the steps, the first step and the most important step really is that you need to make sure that the two variables that you are analyzing are categorical. If they're not categorical, you shouldn't be using chi-square test of independence. Political view and position and death penalty are both categorical variables, so chi-square would be it is justified here in this scenario. Another thing that you should also think about is which one of these two variables is the independent and which one is the dependent variable. Political view presumably might impact someone's position on the death penalty. It is less likely for the opposite to be true. And so, in this scenario, political view or ideology really seems to be the independent variable, and the position of the death penalty seems to be the dependent variable. Once you have that figured out, you should state the null hypothesis and the alternative hypothesis. The null hypothesis is always going to say that there's no relationship between political ideology and position on the death penalty. The alternative hypothesis is going to say that there is a relationship between political ideology and position on the death penalty. So now that we have all of those things figured out, we can go to SPSS and run the analysis. But before we do, we always want to inspect the data. So before running a Pearson's correlation coefficient, we want to create a scatterplot and inspect the data visually. The same thing for chi-square, but instead of doing a scatterplot, we would do a contingency table or a cross-tabulation table. So to do that, we've done this in the past. To do that, you're going to go to descriptive statistics, crosstabs. The variables are in the bottom. Because political views or ideology is the independent variable, convention dictates that we place it in the columns. View of capital punishment as a dependent variable goes in the rows. And you always want to ask for these column percentages right here. Gonna click continue. You can ask for a cluster bar graph if you like as a visual aid, and you click OK. Now, what do you see? Each column represents a political ideology, and each row represents whether or not the respondents favor the death penalty or oppose the death penalty. So when we look at who favors the death penalty, we see that the ideological group most likely to favor the death penalty is conservatives, followed by moderates, followed by liberals. And the reverse is also true when it comes to when we're talking about who opposes the death penalty. Liberals are more likely to oppose the death penalty, followed by moderates, followed by conservatives. So there seems to be, as illustrated by the bar graph, there seems to be a trend here. There seems to be a pattern here where liberals are less likely to favor the death penalty, more likely to oppose the death penalty compared to their other ideological counterpart. So there is a pattern. The question is, does that pattern, does the differences that you see here between the ideological groups, do those differences constitute a significant relationship? And that's why we use chi-squares. To conduct a chi-square, we're doing exactly the same thing. We're going to go to analyze descriptive statistics, crosstab, and you have your independent variable in the columns, your dependent variable in the rows. All you have to ask is for the statistics. So in statistics, you click statistics and you're going to ask for chi-square. Now, chi-square only tells you whether or not there is a significant relationship between two categorical variables. It does not tell you the strength of that relationship. So for that, we're going to click on phi and Cramer's V. And for the purposes of this class, we're always going to be using Cramer's V as a measure of strength between categorical variables. You're going to click continue, and then you're going to click OK. And here you're going to have your chi-square test and Cramer's V, your measure of association, right? So really what you care about here is the chi-square value, which sort of represents this it's representative of the difference between the observed frequency and the expected frequencies, and the p-value, which tells you the probability of seeing this chi-square value by a random chance. Because this p-value is less than 0.05, we would conclude that this relationship the pattern that we observe it was not created by fluke. Rather, it is representative of a significant relationship between political ideology and views on the death penalty. Now, to find out how strong this relationship is, you will have to go here to the symmetric measures of strength of relationships. And when we look at Cramer's V, we see that Cramer's V equals 0.16, which represents a weak relationship. So how would you write this up? Because reporting is really the most important, the most important aspect of this. So you will write something to this effect, that there is a statistically significant relationship between people's political views and their perception regarding the death penalty for murder. And you will tell me what the chi-square value is and whether or not the p-value is less or greater than 0.05. However, even though there is a significant relationship, according to Cramer's V, that relationship is weak. All right. And then you should probably also tell me a little bit about what the findings are from the cross-tabulation table.